Hi, everybody. Let's see. Oh, yeah. My audio's working good. So where did we end up? We ended up here. High order functions. So why don't we just move on and see what this talks about. Okay, Rust provides higher order functions. These functions take one or more functions and produce a more useful function. Lovely. This and lazy iterators give Rust its functional flavor. All right. Oh, okay. As in functional programming functions. Okay. All right. That's functional flavor. So I don't know if anybody, if you're familiar with functional programming, it's kind of the cool new thing. All the cool kids are doing functional programming. So and all the cool programming languages are also implementing functional programming. So basically, if I was to summarize what it is, it's I don't know. Let's see. It's like it's kind of like if you're familiar with SQL or SQL, it's like rather than saying what you wanted, or in imperative programming, you say how you want something to happen. In functional programming, you would say what you want to have happen, and the whatever figures out what you're doing. The other thing with functional programming is this concept of immutability, which I guess, given what we've just gone through here, immutability kind of makes sense in Rust, because by default, if we don't declare it, then variables are immutable, cannot be changed. So that's kind of cool. But so and it ends up like, for instance, in C#, you'd end up with some kind of chain of functions that you would pass something onto. So link is, if you're familiar with link, it's a really good example where you can do like a some list dot where, which filters it, or dot order by, which sorts it, and then a bunch of other things. In JavaScript, you have find and what was that? Sorry, I'm losing my JavaScript. So map and what's the word? Oh shoot. Anyway, so there's map, there's find, there's some words I cannot remember anymore in JavaScript that are similar kinds of functional style programming things. So let's see what they've got here. So we've got main. You got this is odd. You got a main, and here is the imperative approach. Declare the accumulator variable, and then iterate to infinity, and square the number. If squared is greater than or equal to upper, then we break. Otherwise, okay, so we're looping. So this is how we're going to get out of the loop, is by using upper here. Upper is 1,000. Okay, find the sum of all the squared odd numbers from under 1,000. And then if it's odd, if the square is odd, then we accumulate it. And then we have an accumulator, and we mark that one as mutable. Okay. So there we go. That's the kind of write a for loop. And the functional approach, of course, we don't write a for loop. We do map, filter. Oh, there we go. See, there's map. And so this is a similar kind of idea. we want to map n to n squared, take while. So we're saying, hey, if n squared is less than upper, okay, and then filter, make sure n squared is odd, and then sum. So we're saying from here to infinity, do this. Okay, so this is the same kind of idea. So basically, yeah, sure, okay. Pretty much, like I said, C#. I don't know if Java has this. It's been a long time since I've written any Java code, but I'm guessing that it must at this point. You know, if you want to keep up with the Joneses, you've got to have this kind of stuff these days. So, you know, JavaScript has similar things. Again, the keywords might be different. You might do this in a slightly different way, but, you know, so for instance, in C# that would be a select, and that would be a where, and I think you might end up combining these two maybe, and then sum is sum. But yeah, it's basically the same kind of idea. So, you know, create a list. Although this one has the feel of this one has the feel of it, you know, because I guess the way I've always pictured the C# one is that here's a list passing on to the next guy, which is also a list. But I suppose this feels more like it's doing all of these steps for each number, as opposed to accumulating the whole list of things and then moving on. But maybe I'm wrong here. Maybe this actually, I have no idea. Maybe this takes the whole list of numbers, but that wouldn't be possible, because if that were the case, then this would go on to infinity, right? The first step would never stop, because it would say, okay, forever, multiply every number by itself. And then it would never stop. And then you would never get to step number 2. So obviously that can't be true. So at least needs to combine steps 1 and 2. Anyway. So, all right. Oh, that's interesting. Okay. So it's doing some kind of, I guess it feels like it would be doing for each thing. Okay. All right. So there's nothing to do here. Just kind of more stuff to read. All right. Cool. We can do this. And I guess the other point is we can chain this, right? So it's dot this, dot that, dot the other thing. And we're chaining all of these because the output of this can be the input of that. But I wonder how it actually implements it and what the... But yes, it must kind of do each thing for each number. It goes as far as it needs to. And then if take while, then it exits. If filter, well, that's kind of weird though, right? Because take while, when this is above the upper limit, then it just stops. The whole thing just comes to a stop. Whereas with filter, if it's not odd, it doesn't stop, it keeps going. So, okay. All right, so this must have a break in it. Just get out of this whole thing. Whereas this thing just says, okay, well, I'm either going to return it or I'm not. And then sum just says, sure, give me a number and I'll add it to some accumulation. And then return that number eventually. Okay, interesting. Yeah, so I'm not quite sure how they implement that internally, but there's some funky stuff going on here. All right. Okay. All right. Diverging functions. Diverging functions never return. They are marked using exclamation, which is the empty type, which is an empty type. Really? As opposed to all the other types, this one cannot be instantiated because the set of all possible values this type can have is empty. Note that is different from empty, which has exactly one possible value, so that's not really empty. For example, this function returns as usual. Okay. All right, it's very useful and often handy. All right, so why? Explain to me why this is handy. The main advantage of this type is that it can be cast to any other one and therefore used at places where an exact type is required. For instance, in match branches, this allows us to write as code like up to. Notice the return type of this match expression must be U32 because of the type of the addition variable. Match, the I variable is of type U32, which is perfectly fine. On the other hand, the continue expression does not return, but it is still fine because it never returns and therefore does not violate the type requirements of the match expression. Ooh. Where is the exclamation mark? I don't. Sorry. They're saying that is there a data type that has an exclamation mark. Where is this exclamation mark? Because here it says returns exclamation mark. Now we have a function here, function main, doesn't say anything. Function sum of odd numbers, which says that. Up to. Continue. Oh, continue. Oh, continue itself is a function. Really? Is that true? Is that what this is telling me? Is that continue expression does not return U32, but is still fine because it never returns. So continue itself is a function that returns an exclamation mark. But it can be cast to, but okay, since it never returns a U32, it's okay. Oh boy. So that's what's going on here. Interesting. Interesting. Okay. It's also return type functions that loop forever, like network servers or functions that terminate the process. Exit. Okay, sure. Cool. That's a really interesting tidbit to tell me in the middle of here. Like, who actually really cares? Why is this in a tutorial at this point? Don't make any sense to me. Oh, that's cool that we have this exclamation mark thing and continue, which you kind of imply but never actually say, appears to be of an actual function that returns exclamation, is my guess. But you don't say that, so who knows? Okay, fine. Whatever. Moving on. Modules. Module system. Okay, well, all right, so we have public and private. Yay. All right, well, this makes sense. I mean, you know, back in the old days, when I was first writing C code, it was one massive namespace. Everything was in a single namespace. And you'd have collisions. You know, you'd have include this file, include that file, and if two of the, or, you know, include something, so you have include files, and if they were the same name in two different include files, they would collide, and then you'd have to say, okay, in this particular case, I want to include this, but not that, and over here, I want to include that, but not that. So it was just a disaster. One of the nice things about Java and C# is that you have namespaces. So I can create a DLL or a library, whatever, and my library has its own namespace. So then I can reference things in that namespace, and I can call them whatever I want to because my namespace is never going to collide with anybody else's. JavaScript had that same problem of not having namespaces up until fairly recently. But now with JavaScript we've got, and actually, of course, because it's JavaScript, we've got two different ways of you know, you can either say require or you can say include. And in that situation, we've got namespaces, but we can rename things if they. Anyway, it's weird. JavaScript has its own funky little thing, but looks like this has. I mean, if this is modules, the way I think of modules, then you know, this is kind of a real grown-up language. Oh, cool. Okay, visibility. By default, items in a module are private, but this can be overridden with the pub modifier. And then we've kind of encountered the pub modifier. Didn't really know what it was and why we had it. The only public items of a module can be accessed from, only the public items of a module can be accessed outside the module scope. So we've got module, oh, there's the syntax, mod, my mod. So we're into short forms, are we? Mod, fin, pub. This is like, so we, in C, we used to do this all the time. Everything, and actually, generally speaking, it was drop the vowels. So you have print, you know, print line. That's why there's L, it's not L-I-N-E, because you just have the, you know, ln to specify that. And, you know, we used to do that because there was no code completion. Editors were pretty dumb, relatively speaking, and so, you know, you have to type out the whole thing. So programmers, being the lazy people that we are, nobody wants to type out a whole big variable name, so thus, you know, or function name or whatever, so we'd end up with like X and, you know, like single letter variables and whatever else. These days, editors are smart, you know, and so it's not that big a deal to write, you know, full things out. But I guess we're in Rust, where Still going to keep it nice and short. Okay, for reasons. Which, that's why we did it back then. There's no reason to do it this short anymore, but whatever. Okay, so we have a private function because we didn't say pub, and there's public functions. Okay, pub. And then private nested, pub crate. What's this? Oh, here we go. Pub crate makes functions visible only within the current crate. Ooh, internal. So in C# that would be called internal. Here we've got other things. Sorry, I scrolled past that way too quickly. Okay, so what do we got? There's a private function. Functions declared using public in path syntax are only visible within the given path. The path must be a parent or ancestor module. Okay, pub in crate my mod. Okay. Pub self. Functions declared using pub self syntax are only visible within the current module, which is the same as leaving them private. Okay, pub self means private. There's a couple of schools of thought on that. In C#, for example, you can set up the rules, the formatter, to explicitly say private on everything that's not public, or you can turn that off, because just like here, the default is, if you don't say anything, the default is to be private. Now, C# also has a this idea of internal. So if you create a library, and your library has multiple files in it, which, if it's a moderately complex library, it will, then you would you'd create some stuff internally, which you want to have sharing among your files in your project, but you don't actually want them external. So public makes them external, internal makes them outside the file or class, but inside the, actually it's really outside the class. But since a lot of the time what you do is you create, in C# you would create one class per file. It's kind of the same thing. And then you've got the public, which is like outside, everybody outside can access this. Now this one here though is the super one is different. That's something new, I think. Functions declared using pub super syntax are only visible within the parent module. Okay. So my mod nested public function in super mod. Oh, nested. So my mod. All right. Okay, public function in my mod. So, well, wait a minute. Oh, okay, sure. Yeah, because this one is, this is weird. So you've got only visible within the given path, and you can say, hey, the path that I am, so why would you do must be a parent or ancestor, or only visible within the parent? Okay, so this gives me fairly fine-grained control because this one is just the parent. This one is the parent or some other ancestor, which means that, multi levels deep. I can access things, multiple levels down, whereas this one is like just one level down. This one is I can't get it at all. This one is also private. This one is just generally accessible by everybody. I'm not sure. I mean, maybe this kind of makes sense, but I'm not sure when. Because, generally speaking, so in C#, for example, pretty much we just, anything that's public, we just make it public. And that's the end of that. I mean, if you're a library writer that, you're creating a library for other people to use, then you probably take advantage of internal. But for the most part, that's not, I mean, the vast majority of C# developers are not that guy. And so you basically just declare everything public and be done with it. That's interesting, though. We have all this fine-grained control, or if somebody felt the need for all this fine-grained control. I guess if you're a Rust writer, you're doing a lot more library writing, or you need all of this control. Okay. And what have we got here? Private nested, whatever. Okay. My mod nested function. My mod indirect access, my mod call. Okay, whatever. Okay, so what have we got here? We've got all these errors because, okay, that's private. Right, private is private. Private is private. Private nested is private. Private, private, private. Okay. All right. I believe it. I don't really need to uncomment these lines. Whatever. It's all good. Structs have an extra level of visibility with their fields. Oh, good. Visibility defaults to private and can be overridden with the pub modifier. Visibility only matters when a struct is accessed from outside the module where it is defined. Oh, okay. So pub struct, pub contents, pub struct close box contents, close box, pub function new, close box. Okay. So this is the module my. Now in main, right, we can't do this because contents is closed, but we can probably do a new and pass in. Okay, sure. We can use the constructor to create it. Oh, okay, so that's all right, here we go. So the open box, we can just do what we did, like just the curly brackets and bam, populate that. But here we need the constructor, the new, to populate it, because here the constructor new had a contents, and this is able to create a contents. Okay. Sure. Sure, why not? Okay. Cool. Moving on. The use declaration. The use declaration can be used to bind a full path to a new name for easier access. It is often used like this. Use create deeply nested. My first function. Oh yeah, we did this. We've encountered this already. The use, where we've had these. Then we did that in the print, I think, where yeah, we had. I think it was print. where we're implementing print, and we were able to access those variables from that way. Okay, you can use an as keyword to bind imports to a different name. As other function. Okay, so we can give it a different name. So that's kind of handy too. Again, C# has something similar in their using statements. They use the using keyword. Here it's the use keyword. I know this is going to kill me. Okay, deeply nested, sure. Because deeply nested function. Deeply nested function. We want to call that one. Yeah, okay, cool. Okay. Alright, super and self. Super and self keywords can be used in the path to remove ambiguity when accessing items and to prevent unnecessary hard coding of paths. Okay. Mod, we got a mod for cool, a module cool, and a module my, but we also got another module cool inside my. Indirect call. Self cool function. Oh, okay. All right. Self function. The self keyword refers to the current module scope. Okay, yeah. So self allows us to reference anything inside my, but we can go, but here if we go super, we're saying, hey, outside this scope, like outside the module, which then we can refer to everything here, which includes, right, we've got that. So it's going to include cool and my in super. So super includes all of this, I guess. Okay. All right. File hierarchy. Modules can be mapped to a file directory hierarchy. Oh, okay. So we can put separate files. This declaration will look for a file named myrs and will insert its contents inside a module named my under this scope. Oh, okay. So we have my. Wait a minute. Whoa. Mod my will find this one. Okay. In my. Mod inaccessible, pub mod nested. Oh, hang on. What's going on? What? Oh, excuse me. Yes. All right. All right, that makes no sense to me. All right. So we're trying to show a hierarchy. So the mod my says I'm going to look for a file named myrs and put it here. Okay, and that's what split is going to do, in split. So in my, we're going to say mod inaccessible. Similarly, mod inaccessible and mod nested will locate in the nested RS and inaccessible RS and insert them here under their respective modules. But, oh, okay. Well, hang on a second. So why did this one why did this one look for my.rs, but this one not look for inaccessible at the top level? It looked inside my, it knows to look inside my? Unless it hunts the tree. Is it hunting the tree? Looking for these things? I don't understand why would, how does it know, or does it always? And if it always, unless, on what you're trying to tell me, what if there was no my RS? All right, I need to play around with this. All right, so what happens if let's try this thing here. All right, let's create. There we go. All right, we can close this. Close folder. Okay, terminal. New terminal. Cargo new. Module. Okay. All right, so file, open folder, repos. Oops, sorry. Rust. Not repos. Modules. Oh, I always do that. Double click. Select folder. Okay, so now in source we have main. So this thing, all right. So we're not going to, you know what? Fine. Let's flip back here. So we're going to call, instead of calling this split, we're just going to use main for this. So we'll just copy this. And we're going to copy it into main. So let's select all. Okay. What's this? Quick fix. Oh, look at this. Create a module at my RS. Oh, so if I say, hey, that's interesting. Okay, sure. Why not? Or but create a module at my/mod RS. Oh, it can go either way. Clever. Okay, so here we go. Boom. Well, you didn't actually do it. Unresolved module. Can't find module file in my RS. Quick fix. Create a module at my RS. Well, that's the quick fix. Do it. Oh, there it is. All right, so target debug. Yeah, we don't know that. So there's my RS. Okay, my RS is empty. Okay, so my RS, let's copy that. And we'll paste it here. Oh, okay, here we go. And now this says, let's save that. And this says, hey, quick fix. Now, oh, and this one says, sure, this is where it has to be. Oh, so this is interesting. So basically it's saying it should be here. Okay, let's create that. Let's click on that. And there's the my directory, and there's inaccessible. Okay, so let's click on that, and let's go grab inaccessible. This is this one. Copy. And paste. Okay, save that. Back to this one. And quick fix. Create that one. So there's my nested. Okay. And we'll go to that one. And where there you're nested. Copy that. And paste there. Okay, so save that. Save that. So now everybody's happy. So if I run this, okay. So it called my function, called function, called my nested function, and called my private function indirectly. Because I'm calling private function from within here. I'm calling this one from within here. You can't get at it directly, right? But you can get at it. Here, let's do this. Because if we said my private function, so if we try to call my that says, what's the error say? Function, private function is private. Okay, so it recognizes that private, so it'll, in the error message, it's telling you, yes, this guy exists, but you can't access it because it's private. So, but if I change the name to function 2, which doesn't exist, now it's going to say, cannot find function 2. Okay, so we're going to be able to tell the difference between you made it private, dummy, and doesn't exist. And that's a fairly common thing to do, right? Because if you don't say anything, it's going to be private, and then you recognize, oh, right, I need to call it. And so you have to go back and make it public. Because if we stick pub in front of this, then back in here, oh, that's interesting. Why is that an error now? Oh, yeah, because you're showing me the old error. My private function. Yeah, see, it even does the code completion. Okay, that's cool. I'm going to put it back. To being private. Okay. Oh, and I'm going to make it pub self. Because I'm going to explicitly make it private. So if I If I uncomment this, still an error. Private function is private. Okay, so it recognizes, it doesn't say, oh, and private function is pub self. It says it's private. Okay. Now, these nested ones, so that's a private, oh, there's a function, my nested function. Okay, that one got called. How did that one get called? Oh, there, my nested function. So I'm able to access the namespaces. So if I do mod my, so this is a little different. Oh no, this I guess is not really different. Because in C# you can do the same thing. Because although in C#, you know, I guess this is kind of like a using statement. I say I want to use this module. And in C#, if you just say without this, if you say my, it still works. Because C# will go, oh right, there's a namespace that is in your project. So you can just reference it directly. And it's done with dots. So it's like my dot nested dot function. But here we actually have to start the chain. We don't have to list. I wonder if we can. Mod my nested. Can we do? No, we can't do that. Oh, you expected all sorts of things, but you didn't. Yeah, this is just invalid syntax. You can't say, you know, because I was thinking maybe you could do something like this, where you go, hey, I want to refer to only the nested stuff from my in this particular instance. So if I had like multiple files, I might say, no, just the nested stuff from my in this file. But looks like I can't do that. So I need to specify my, and then if I want to drill down, I've got to always start at the my level and drill down into there. I can't kind of accumulate this up into okay. All right. But I can do the as thing, right? How did that as thing work again? Because I think it was use my nested function as fun2. Okay, so I could do that. So this is a way of doing it. And then I can call fun2. And if I run this, yeah, there you go. Called my nested function. 2 different ways. Okay. So I can do that. I can do this. So this is kind of like more like the C# thing I was thinking of. Is, hey, I can take a shortcut. Now if I do this, can I get rid of this? Or does this no, that fails. Because it says I don't know what my is. Okay, so I still need to declare the module. Okay. I guess C# has a similar kind of thing where you declare the module because they call it references, but they keep it in the project file instead of in the code. So okay, yeah, similar thing. Yeah, I mean it's none of this stuff is magic, right? You got to do it somewhere. So in the C# case, it would be in the project file. JavaScript, yeah, it's like, yeah, you can do a similar kind of thing where you can rename stuff. Syntax a little fuzzier today. Okay. All right. Cool. Yeah, that's fun. All right. Let's move on. Why do we have 7 changes? Yeah, because we created all these files. All right. We'll commit that later. All right. So that's file hierarchy. So that takes us through modules. Do we want to... What's crates going to do for us here? Let's move on to crates. Oh, there's just creating a library, using a library. All right. So we're getting into this like stuff, and I don't really feel like I can write any code in this language yet. But we're getting into this, and it just feels weird. But all right, I'm going to follow along. I started following along. I'm going to continue to follow along. All right, but this looks like it'll be quick. So a crate is a compilation unit in Rust. Whenever Rust sees some file is some_file.rs, it's treated as a crate file. Has mod declarations in the contents of the module. File will be inserted in places where mod declarations are found before running the compiler over it. In other words, modules do not get compiled individually, only crates get compiled. Okay, so this is like this old style C includes, because, or actually maybe like PHP includes if you've used PHP, where you can visualize it as take this whole contents of this file and plunk them here. But with namespaces. A crate can be compiled into a binary or into a library. By default, Rust-C will produce a binary. This behavior can be overridden by passing the crate type flag to lib. Cool. Creating a library. Let's create a library and see how link. Okay, so we create a library. So Rust crate type library, whatever, and then we've got a library. Libraries get prefixed with lib. And by default, they get named after their crate file, but this default name can be overridden by passing the crate name to Rust-C. Crate type lib. Crate type lib. Rary. Very funny. Very funny. So you created a file called Rary, and it ended up being library. So, but typically it would be lib some stuff I'm doing. So it'd be lib decoding, or lib filter, or lib whatever, passwords or whatever. Okay, so then crypto, libcrypto.rs, find me that, and we have an extension of rlib. So really, so we need the lib in front and we need the lib at the end. So we're going to do lib lib. Why? Okay, all right, fine, whatever. So crate name option to Rust-C, or using the crate name attribute. Ooh, what's a crate name attribute? Crate type. Oh. Crate type lib. Crate type rary. Okay, fine. Back there. Okay, that's in section 13. Okay, using a library. To link a crate to this new library, you may use Rust's extern flag. All of its items will then be imported under a module named by the same as the library. Module gender behaves the same. Okay. Oh, rary. indirect access, where library is the path to the compiled library. Assume that it's in the same directory. Externary edition executable. What? Really? That's kind of overcomplicated, don't you think? So it's in the command. Oh, we have to specify in the command line. All right. Sigh. Hopefully, there's some way of specifying this that we don't have to use the command. We don't have to modify the command line, because I kind of like the Visual Studio Code ability to build, but how is it going to deal with it? Alrighty then, I guess we have to find out. Let's go back. So let's create this library. But we're going to use the attribute because there's no way I'm doing this. Okay. All right. Let's create another one. Let's create another one. Where are you? Where are you? Where are you? There you are. Okay. No, you know what? I'm going to reuse this. So I'm going to create a new instance, I guess. All right. Let me think about how to do this. So what I want to do is I want to create a library. And then I want to use that library. All right, that's fine. We're going to close this folder. Terminal. New terminal. Cargo. New. Test. Yeah. Test loop. Okay. And now file, open folder, Rust. Test lib. Where are you? Test lib. Test lib. Okay. So now create a library. So this so let's plunk this down here and I guess. Okay. Rename. testlib.rs. Okay. Cargo check failed. All right. We're going to here. We're going to use the create name attribute. So let's do this. Let's take the crate type. I don't actually care about the crate name. I just want the crate type. Cargo check failed. Rust analyzer failed to load workspace. Yeah, whatever. So, terminal. New terminal. Oh, okay. So I'm kind of stuck. Because it's a library, I can't actually use run here. So I actually need to use the command line. Let's go back. I actually need to use the command line here. So rust c testlib.rs. It's there. Oh, it's under source. Change directory source. And then that's, by the way, that was the up arrow twice to get the previous command back. All right, there we go. So there's a libtestlib.rlib. We have enough, I think we have enough libs. And notice the size of it. So it's bundling some stuff. Obviously not just our code. There's a bunch of stuff going on in there. Okay, so we've got that. Now we're going to copy this. Copy libtestlib.rlib to c:/rust/modules. Okay, and now we're going to, so we built that. File, close folder, file, open, where are we? Open recent modules. So now if we do an ls here, there it is, there's libtestlib.rlib. And so we should be able to include it here. Creating a library. Okay, here. And extern. What's this? Okay, is there any way to link a crate to this new library? You may use rustc's extern flag. Okay, but I need to say extern, huh? Executable.rs. This file is main. What's executable.rs? I'm assuming rust c main.rs extern testlib equals libtestlib.rlib. Could not read. Oh. Source. I did it again. Okay. What happened here? Something changed. Oh, there's a main.exe and a main.pdb now. Main. Okay. So, mouse properties. If I execute main.exe, it's in the source directory, is it not? Yeah, it is. So it's here. Main.exe. Yeah, you can't edit this. But oh yeah, I guess I can do /main.exe. There we go, it runs. So yeah, it runs. It was just a Windows thing. So it does that, and now if I in here, now in this code, oh yeah, so it just went rary. So I'm just going to call it, because they called it rary here. So I'm just going to say test lib. What's in test lib? Public function. Okay, that's giving me an error. Oh no. Failed to resolve undeclared crate or module test lib. So if I say mod test lib, well, but that doesn't work. So why did that work for you? I don't understand. I'm looking at this going, do I need to say this? Extern crate rary? Oh, extern crate test lib. No, that's not doing it either. What's your complaint? .so or DLL, my C library would attempt to link at runtime, panic if it can't find anything. Can't find crate for test lib. Quick fix. Oh, spelling mistake. No. Yeah, I know. But so I don't get it. What's going on here? How come this one, they claim this one will work? Or will this one also, where library.rlib is the path to the compiled library, assuming that it's in the same, yeah, so library, I did that. And we were able to build it. All right, well, let me see if I can build it. So here, we calling, so let me just take that and take it out of its misery. Okay, now if I build this again, it didn't save, shoot. All right, let's try it again. No, it's saying no. Extern location for test lib does not exist. Lib test lib.rlib. Well, sure it does. In fact, I even told you where it was. Right there. So, what is going on here? All right. That's enough for today. I'll figure this out, and well, hopefully I'll figure it out and update as comes along. But anyway, I'm done for now. Thanks for watching.